Hello everyone, and welcome back to another cartography lecture video. And in this lecture video, I want to wrap up our discussion on distortion by talking about some of the key terminology that we need to know as cartographers to be able to make decisions on map projections based on what types of distortions they address and what types of distortions they allow. Now, at this point, map projections can become very math-focused. And I don't necessarily think that that's relevant at this stage, because when we're making maps, we don't necessarily need to fully understand and grasp the mathematical underpinnings, as long as we know the terms to look out for and what those terms mean so that we can make meaningful decisions. And so just like when we were talking about the idea of class, case, and aspect for describing map projections, we can also use the types of distortion that they address to describe map projections. And so we'll typically see a blend of those two types of languages in the description of map projection. And so where we left off last time was we had just sort of outlined that maps can be distorted in four key ways. You can distort the shape of an object, you can distort the area of an object, you can distort the direction in a map, or you can distort the distance between points in a map. And what we can do is we have, again, setting the math aside, we can create these different map projections so that they address these four fundamental types of distortion differently. So if we want to have a map that addresses this idea of shapes and angles, what we're going to want to look for is we're going to want to look for a map that is labeled as conformal. Right, a conformal map projection is going to address the idea of shapes and angles. Now, I want to make clear here that this only is true over small areas. And again, if we go back to that idea of secant and tangent cases, when you get farther and farther away from those secant and tangent lines, you're going to have more distortion. So conformal map projections deal with this idea of shapes and angles over small areas. The second type of map projection that we can have addresses the idea of aerial distortion. And what I mean by aerial distortion is you would be looking for something called equivalent or equal area. So you'll see either an equivalent projection or an equal area projection. Right? If you see either one of these terms, you know that this is going to be trying to preserve area as much as possible. Okay? So if you're doing anything that requires you to want to be concerned with the area of an object, you're going to want to go with either an equivalent or an equal area projection. Third, we can preserve direction. Now, direction is preserved by something called an azimuthal projection. Now, I want to be clear here because this is where we start to get into a very special sort of definition here. With azimuthal projections and dealing with distortion in direction, azimuthal projections only work from one point. To from every other point. Right, and so if you think back to that idea that we laid out when we were talking about the planar class, how when we diagrammed it out in terms of where the graticule went, we ended up with that point in the middle of expanding concentric circles. Right, that is an azimuthal projection, because that point in the middle of the map is going to be proper in terms of direction to all the other points in the map, and all the other points in the map are going to have a proper direction to that point, but they will not have a proper direction between each other. Hopefully that makes sense. I know this is a little bit confusing. With azimuthal projections, you get one point. You get one point where the direction is preserved. With distance, you will typically see them called equidistant. equidistant projections. Now, equidistant projections, similar to azimuthal projections, only work for a select number of points. So hopefully, again, you just kind of have to memorize these four terms. Conformal means that you're addressing the distortion of shapes and angles. Equivalent or equal area means you're addressing the distortion of areas. Azimuthal means that you have one point where the direction is preserved. And equidistant means that you are preserving the distance between a select number of points. Hopefully this all makes sense. And as always, if you have any questions, please reach out. Thank you.